Thank you, and thank you for coming. So first, let's start with the picture of the solar system that I had in my mind when I was a kid. We have 8 things in the solar system. We have the 4 rocky planets, Mercury, Venus, Earth, and Mars, and we have the 4 gassy planets, Jupiter, Saturn, Uranus, and Neptune. Maybe you heard about Pluto at some point later in your life, but I'll talk about that later on. And that was it. This is the entirety of the solar system. Turns out that the picture is much more complex than that. And the solar system looks a bit more like this. There are over 1 million bodies orbiting the sun, and most of them live in this region here. So this is a map of the solar system. Here is the sun, here's the Earth, that's where we are. This thick region here is the asteroid belt, and we have millions of things over there. I will not talk about the asteroid belt here, but rather I'll talk about another belt. This one. This is the Kuiper belt. This is the outermost region of the solar system, and there are about 3,000 known things here. This region is also called the trans-Neptunian region, and there's a very obvious reason to that. This is Neptune, these things are farther than Neptune. The things in the trans-Neptunian region are mostly made of icy materials, such as water and ammonia, and they are not similar to the other 8 planets. So you have an idea of what these things look like. Let's take a look at these 2 images, if I can change the slides. The one on the left is Pluto. Pluto is a dwarf planet and also a Kuiper belt object. It has a diameter of about 2,000 kilometers. This one is Arrokoth. It's a 30-kilometer body that was discovered in 2014, and this is a very interesting example of one of the things we have there. These images were taken by the NASA New Horizons space probe, which is currently in the Kuiper belt. That's why they look like this. So what do these things look like when you see them from the ground? So the first thing we need a telescope. This is the Blanco telescope. It's located in a mountaintop in Chile. And I'll talk about a project called the Dark Energy Survey, or DES. DES took images between 2013 and 2019 of about 1/8 of the night sky. And the goals of DES are to study the nature of dark energy and dark matter and understand galaxies in the universe. So DES is not about the solar system. This will make things a bit harder. Oops, I moved 2 slides. This thing here is called the Dark Energy Camera. That's the instrument we use to take our images. And DCAM has the area of about 10 full moons on the sky and has 50 times more pixels than a camera in your phone. So it's a very fantastic instrument. And this is one example of the images we took. This frame here has one of the TNOs I discovered, this red one here. And I'm sure you can see it from here, right? If you do, you have much better eyes than I do. So let's start zooming in. Maybe this will make it easier. Maybe it's this thing here. No, it's not. That's a star. Maybe it's this. That's actually a galaxy. So let me help you. There it is. You probably still can't see it. So let me zoom in once more. Here we go. This thing has about 150 kilometers in diameter, and that's why it's so hard to see. And I would be surprised if you believe me that there's actually something there, so let me try to prove it to you. These are 6 images we took of that thing in many different nights. And the idea is that since this object is moving, it appears in different places on the sky every night we take an image. So these 6 images were taken in different places. The object is moving and the Earth is moving, so that's why this thing moves on the sky. Let me once more try to convince you that this is actually real. And this image combines all the 6 images into one. This object is called 2014 WB556, and there's a very obvious reason for this name. It was discovered in 2014 and first observed in November. Once this object is confirmed, we can actually pick a much more interesting name for it. For example, Arrokoth was once called 2014 MU69 because it was discovered in 2014. So the idea is, how do we find these objects and how do we know they're real? We need to go through all the images that DES took, and there are 80,000 of them, and find everything that only shows up once at the same place, find when they went next, and trace their paths on the sky. As you can imagine, this is very hard. The first reason why this is hard is that DES doesn't take images side by side. So our images of the same place only come many days later. So the thing is already gone and we can't really find it. So what we have to do is we have to play the world's hardest connect the dots game, where we have to find these 6 dots among 22 million other things that also show up only once. And we have had to use the equivalent of over 100 years of computer time to do this, also trying to solve one problem. And well, the reason why I'm giving you a talk is that we obviously were successful. And we found, whoops, Can someone help me here? I don't know what happened. There we go. And we were successful, and we found 316 things. And 139 are new. By the way, you see this red donut here? This is Neptune. And this thing is 2014 WB556. So what do this color means, and why do we actually care about these objects? Well, first, these objects group themselves in 4 different families, with different properties and different histories. The classical objects formed 4.5 billion years ago in the orbits they currently are. The resonant objects, they are trapped in a sort of dance with Neptune, where every time Neptune completes a certain number of orbits, these objects complete another number. For example, Pluto is one of those. Pluto completes 2 orbits every time Neptune completes exactly 3. The scattering objects have their orbits changed by Neptune currently, and they formed closer to the Sun than where they are now. The detached objects were initially scattering, but now are totally free of Neptune's influence, and are very stable for long periods of time. So the idea is that understanding the similarities and differences between these families and the processes involved in their formation is a very powerful tool to study the history of the solar system. We can probe where the Sun was born in the Milky Way. We can study the detailed formation of the giant planets, and even help shed some light into a current debate over the existence or not of a 9-planet solar system hiding somewhere around here. By the way, this is the type of research that has the potential to actually find that planet. So maybe you guys will hear about this soon. Thank you for your attention. For more information, here's my email, here's a link to the paper, and stay tuned for an upcoming Penn Today story about this work.